Good morning, everyone. Welcome to our new series of Introduction to LabVIEW. In this series, we will see that what is the LabVIEW, what are the environment of the LabVIEW, how you can, how LabVIEW get its importance in this physical world, and why LabVIEW is important. Also, we will see that what are the data types in LabVIEW, what are the basic structure like for loop and while loop in LabVIEW. Then in the next part, in the end, we will see that how we connect a real-time hardware in a LabVIEW. Okay, so today we will start with the environment of the LabVIEW. So you see, whenever you open, if you are familiar or you have installed the LabVIEW, first the installation process. If you want to install, you can go to the ni.com and you can download the any community version or the latest version LabVIEW from there. Then when you install the program, you see this type of window has been opened. So you get the choice whether you want to go to the new VI or you want to create a project. Now there is a difference between a VI and a project. A VI is a file where you only do the simple work, like which is not connected or which is not integrated with some real-time high applications, or we can use we can say that an application which involves a multiple files, a multiple programs in a one main program. For that, we can go for a project creation. So since we are just introducing a LabVIEW, we can go for a blank VI. A VI is a file which is a normal LabVIEW for a normal LabVIEW programming, where you can only simulate, or you can integrate a real-time hardware. Obviously, only the data acquisition process will be done on that, not on the like Rio kind of like which has those using those hardware which has its own controller. In that case, like the Rios, you cannot do the programming on a normal VI file. So let's start with a creation of new VI file. So there are two ways. Either you can use a shortcut like Control N, or you can use a file here and go to new VI. Okay, so this is a VI this is the environment that has been opened after you start a LabVIEW environment. So you see we have two windows here. One is the front panel and another is the block diagram. So LabVIEW, if we say about the LabVIEW component, LabVIEW is a combination of three main components. We will see what are that. So if you want to do that these windows come side by side, you can just go to Control T, or you can just go to the windows and you can see that here you can adjust your window like tile from left to right or up and down. So there are two ways. For left to right, you can also use a shortcut, that is Control T. So using this, we can just keep our files, our windows in parallel position, like side by side. So this is a front panel, the grid kind of windows. It is a front panel. Front panel is basically a user interface a window where all the controls in LabVIEW we say all the inputs as control, or we refer all the controls as all the inputs as control, and all the displays as the indicators. So this is our front panel where all the controls and indicators and graphical representations are there. The blank space is known as the block diagram, where all the programming has been done, all the logical operations, all the functions, and all the algorithms, whatever the algorithm you are thinking, it is all available in this blank space. Now there is a third component also, which is known as the connector pane. This is the connector pane. If you see, connector pane is used when we are dealing in a process of making a sub VI. A sub VI is a function or a VI which has been used inside a main VI. So if I have a VI inside this main VI, then we can say that it is a sub VI. Now, whenever you create a VI, you need to save that file. We have 3 save options. Like whenever you save first time, you can say that save as. And whenever you have like if you have multiple functions available in your VI, like I already told you, we can have a control input in our LabVIEW. We can have a sub VI also. So whenever we want to save all these files, we can say that save all. And there is one option, because at LabVIEW is a tool. It is a software which has been upgraded at every year. So whenever, if you have a 2026 version available with you, and you are doing the program on 2026 version, then you cannot open that file in 2019 version. Now for that, what you can do, you can save for previous version. So whenever I make a program, if I know that at some other computer I have a previous LabVIEW version, then I can go for save a previous version. Now we have here also, you can create a project. You can open a project from here also. Then there is a VI property, which is very important. VI properties in that, like I want to change the environment here. Our VI environment. So there is a general property, like we want to save the location, that which location you want to save this VI. If you want to edit your icon, this is the icon of a VI that you can get. I can change that also. Suppose I want to create something, then I can change the icon from here. I can delete this, and I can put some glyphs here, like suppose I can put here, and I can save it. So our icon will be changed. You see, this icon has been changed. So this is from me. I can separate the compile code from the source file. I can do anything. Okay. This is one general category. Then we have a memory uses. We can have a documentation. You can write a VI description, so that if you are dealing with any consultancy, then your whatever your customer can know that what this VI is using. Then you can have editor options also, like what is the front panel, what is the block diagram. This is the what you can say, it is the font size. So whatever the font size you can have, you can change it. So this is the modern style we are generally used. Then we have a system style, silver style, NSG style also. Then we have a classic style also. These all are the category. You can have a Windows appearance. How can you want a window appear? Like if you want customized, you can have a dialog box also. So this is how you can change. Then we have a window size also. You can maintain the panel size, whatever the size you want. Like you want a front panel in a bigger size, you want a block diagram in a shorter, or you can want a block diagram in a bigger size, front panel in a shorter version. You can do that also. Then we have a print option here also. You can print whatever the VI you can. And for example, if you have any lab in a lab, we have a lab as a virtual instrumentation lab. So in that, if you created a program, you need to print. So instead of taking a photograph and printing that blurred picture, you can directly print your VI, your program using a print option. So these all are the properties that you can have in a LabVIEW environment. Now second is the edit. Suppose there is a very important thing here. For example, if I want to align the items, these all are available here. These are the alignments that we can use. Suppose I'll take a 2 control. Now the second part is we have 2 different kind of palettes here in our LabVIEW. So if I right click on the front panel, then there is a control palette open. This is a control palette. Is you see, if you have all the data types here, like a numeric data types. If I click on that, we have a numeric control, numeric indicator. We have a different kind of numeric like a vertical slider. We have a horizontal slider. Then we have a knobs. We have gauges also, dials also, tank size also, thermometer also. We will see in next how we can create a program here. Now we have a you can have a framed color box also in here. Then you can customize these print panel as a category, icon, or standard. You can have any customized control palette here also. Now whatever the editing I told you, this is the modern style. Then we have a silver style also, in which there is a different kind of appearance of the numeric control, and the vertical and horizontal bars. They are little bit different than the modern control. Then we have a NSG style also, that is very different style as compared to, for example, suppose I'll take one numeric control from the modern style. This is look like here. Then we have one from NXG style. This look like here. Then we have one from silver style. This is look like here. All these are numeric indicators, but all have a different appearance. If we see, all are having a different appearance. Then we have a system style also. This is kind system style. It is different. Then we have a classic style also. This is our classic style. So you see that all appearance are different. You see, this is the classic style. This is NSG style. This is silver style, and this is what we have. It is a modern style. System style, and this is a classic style. So all these have a different style, and you see that all the icons, since LabVIEW is a parallel programming kind of language, you don't need to do extra work. Whatever the control you have taken, for that icon has been appeared in the block diagram. So you don't need to do the multiple tasks at the same time. So then we have a control palette. You can take from here also. If you click from the view, you can have a control palette. There is a one very important parameter that you need. There is a tool palette also. You see, you can change the appearance of this window. For example, it is a silver in color, but if you want to change the color, for example, I want to change it into a suppose in a blue color. I can change that using this parameter. I want to change it the color. You can change the color. You can change the color of the block diagram also. So this is in a blue color or a green color. So this is all depends upon your perspective. Whatever you want, you can change any color here. Let's say a white color. Okay, so this is how the appearance can be changed. Now this is known as the tool palette. You see, this is automatic in an automatic tool selection. Suppose I'll take numeric. So you see, if I don't have a tool palette in an automatic mode, then I'm facing a very problem, because the tool has not been changed automatically. Suppose I want to select something. So this button is for the selection, position, and size. To select, to size, and to position any icon, any object, then you can use this arrow. Okay, so whenever this arrow appear, you have to select this arrow. If you have not automatically select the automatically set the tool palette, so I have not automatically selected it, so I have to go by manual. So I'll use this select option, and then I have to right click it. I got one numeric control. Okay, now I'll get one numeric control. I want to change its value, but I cannot change until and unless I move to this part. Now this is to operate the value. This symbol is to operate. Now I can change the value of this numeric control. Okay, using this system using this tool. Now if you want to write anything, you cannot write now, but using this button you can write now. This is a numeric, okay, data type. We will cover the data type in next session. Then if you want to connect it with some values, with some function, for that you need a wire. So this is a wire palette, but you need to connect it something. Then also you have to manually select it. Then this is to list out the to select or to open out the control. Then we have okay, then we have to change, like to move the all the control and any object. We use this, that is scroll window. Then we have a stop or clear breakpoint. We will see that if when I program something where the breakpoint can be used. We have a probe data also. We have to change the get color, so we can change the color. We have to set a color. Suppose I want to change the color from inside, I can change the color from inside also. Let's take a very bright color. Suppose I'll take this color and I can change the value here. Wait. So I can change the outside, inside value color also. So this is how has been worked. Okay. So mostly we only use it on a like in a automatic mode, because this way it is much easier. Now suppose I have a I want to add two numbers. So what I do, I have to right click it. I'll take two inputs. While right clicking it, I open the control palette, and in control palette you have to select which data types you have or which kind of inputs you need. So I have a numeric, I have a boolean, I have a string, and I have different kind of data containers. These all are the data types. We will see in the next part that what are the data types in LabVIEW. Now suppose I want to add two numbers. I'll take two numbers. Now for addition I need a function. So where is the function available? So for the function you need to go to the block diagram, because all the functions, all the logics are happen in a block diagram. So I come to the block diagram part and I right click it. There is a function palette open. This is the function palette. This is not the control palette. We have a different kind of palettes for the controls and display. For the outputs we have a different palette, and for the functions we have a different palette. So this is a functions we have here. Now we need a addition. For addition we need to go to the numeric module. So this is the numeric module in which there is a addition function is available. Now I just click it and drop it here. So this is like a I already told you in the last session when we dealing with the virtual instrumentation that it is a drag and drop kind of language. You just drag and drop it, and it is a graphical language. You see, this is a numeric data type, so it has some color. So I just connect it. Now I need a output. So for output I again go to the control palette, right click it, and there is a just beside a numeric control we have a numeric indicator. So I just click it and drop it. Now you have to be very specific that which input, output or function you are taking. The function, if you take a function from here and you need to put it on a front panel, then it will not be available, but it is available in a block diagram. Similarly, if you contain some input from control palette from the front panel and you need to put it here, then it is like a constant for here, because it is a constant are something that is not available in a front panel. For constant you need to go here. These are the constants available. Now I need to add this is the addition. Okay, whenever now I need to run it. So there are two kinds of run available. One is this kind of run. This is the run for one time. First time we run, and whatever the value, if I change the value, this is only one time, and then it will stop. But for the continuous running, you can put this, and this is the continuous running. Now I can change the value. You see, I can change the value of the input simultaneously during the running condition. No other platform give you that kind of flexibility that you can change the values of the input in the running condition. But in LabVIEW you can do that, and if I can modify the values in the running time. Now if you want to see your values in a real time also, you can just open this highlight execution. It will give you the value came out from every node. Like this is one node, numeric 2 is another node, and the function is the third node. So every node, what is the value is given out, you can see using a highlighter. It will slow down your compilation speed also. So this is the highlighter. If you want to stop it, you need to abort the execution. This will stop your program. Now again, if you want to pause it, suppose you want to change something, you can pause it. This is the pause symbol, and this become red if you want to pause. If you pause something, and this is how the function is blinking. Now I unpause that. And now if I told you something about the probes. Now probes is something that will give you the real time wire value. Suppose it is similar like a CROs, DSOs. In DSOs you have a probes. So in probes you have connected two wires in a wire, like in a series connection. So similarly, if I connected this in here, then it will give me the value in the current value of this position here. Now if I change this value, it will be changes, and this is the value that at which time, at which point the value has been changed. You can see from here. So this is a probe. Now you can stop it, and yes, I want to close the probe. So these are the on the execution time. These are the debugging tools. The second of all, in LabVIEW, if you have not corrected, if your program is not corrected, then you can see without realizing, without thinking about, like without confused about that where you can get wrong. You see this is the arrow, which is the run symbol. But if you have some problem in your program, then this will show broken. It will showing that you have some mistake in your program. Whenever you click it, they tell you that at which point you have a problem. That is add contains unwired or bad terminals. Okay, if I say that show the error, it will give me the position at which the error has been coming out. So this is how the LabVIEW is very much known for its debugging tool, very good debugging tools. Now this is the addition program, which is a very smallest program we can go through. Now there's something different also, like if you want to align, suppose I have to align these my inputs, then you can align from here, like horizontally or vertically you can align. Now I want to align this in a horizontal manner, you can align it in a horizontal manner also. And if you want to, that there is some gap in between, so you can put that also. You can have some gap in between, you can change it like you have some gap here, so that it will be not be problem to you. Okay, you can have some gap here. It will mostly, these are the alignment tool is available in every spec. So suppose I have connected it, but it is not good. So what I do, I will use this symbol. This is to clean up the diagram, and it will make in a very short format. Now if I change this, because this is the icons take more spaces, so whenever I go for a large program, what I do, I will hide this icons in a simple format. So now this will become more compact, and now if you use this, then you can get your perfect program in a very compact way. So this is basically it is a graphical language. So you move the compilation direction will be from left to right, not from the because in a from now on, from up to, you see all the text based kind of program. Since in a text based kind of program, the compilation is from the top to bottom. So in LabVIEW, we have a free space. There is no lines available. There is no text available. So what we have a compilation from left to right. Now, left to right doesn't mean that if I put this output here, then it will do. It will get the input. No, not like that. Left to right means how the wire has been connected or the function has been going on. Like if I take out this function, then first this the numeric get the numeric values will come out, then it will go to the function, then from function it will go out to the output. So this is like, you can change these value to input and output also. Input A, and this is input B, and this is the output. Okay, so this is the input and the outputs. Now if I change, since if you can't see the value, you can change the size of these symbols, and you can change the font style also. You can have in a italic format, or you can have I have to select it. You can have in a bold format, italic format, or you can have any kind of, you can change the color also. If you want to change the color of these terminals, like I have to select it first, then you can change the color. Like I want to change in a red, and if you want to just main in a center, left or right, you can have these also. Then this is like to change the, there are so many font sizes available if you want. Then if you want to see, we have like suppose I have some function that I don't know what it do. You can just select it, or you can go for a help, show context help, and it will give you, click it, and it will give you the what this function is known as, and it will give you some kind of that it returns the product of the input. So this is the multiply function that is available. Similarly, if you have to search something, you can go for a search. Like if you know some function, like I want to find the divide function, so it will provide you the divide function also. This is one, or you can just click a control space also if you want. You can go control and space, and this is the quick drop has been coming out, and I want a divide function, so it will have a divide function, and I just click it and put it. So this is how the divide and function can be right. You can just take out the wire. It is like a simple electrical wires that you can just connect it in a parallel format, and I can have this, and this is the division, and you can point out data indicator. This is what a divided value. Okay, so here is the divided value. So this is how you can have. Now if I want to put it in a like in a format, in a box or something, that then I can put it in a box, that it is for the demo, and I just quit it and move to back, and I can get my value. So this is something, the numeric, if I put it, and I can change the size, suppose 24, and style can be bold, and this is, I can just write it as the addition demo. Okay, just put it. So this is how you can have. And you can just lock it if you want. I can group it. Group it is very fine. So whenever it is now, it can do. So this is one thing that you can do. Now, if we have a different kind of environment. We have FPGA also. We have a real time, which is again something that is connected to the very high level advanced LabVIEW programming, for which you need a proper hardware for that. So for that, we can go for that. Now, move back to the environment of the LabVIEW again. Now, this is one kind of thing that is available. Now, I want, suppose I want some error and I want some breakpoint here. Then you can introduce a breakpoint in a wire also. Suppose you are working something and you need at some point you can have some kind of breakpoint, like to think about it, or to set something value. So you can put a right click on that and you can go for a breakpoint, and you can just clear the breakpoint, or you can have just disable the breakpoint. But you can introduce a breakpoint here, and I just introduce it. And suppose if I run it, you see there is something breaking happen here, and this is how your block diagram window has been appeared. That is something going on, means it has been paused. Now, if you want to unpause it, you need to disable this breakpoint. Otherwise, it will not make you the work. Now, if I disable it, now if I run it, you see it is running properly. Or you want to clear it, you can go that also. You can go and you can clear the breakpoint. So this is one kind of thing. Now, if you want to, suppose this is our numeric, and if I want to, if I having some problem and I don't know that where this problem is arising, you can always go to these kind of stepping tools. These are the debugging tools. Like if I want to see that at which point I'm having a problem, then it can go here, and then at each point it will check whether if that function is having problem or not. So at each point it will go. Okay, I think it has not. Wait. Now, so at each point it will go. Now, if it is a single stepping, then it will go by single value. Okay, and if it is like if you want to go for if you want to start, you can go for the start also. This is to finish at the direct to go to the block diagram. So like it is a start a single stepping, then it is like jump to the single. This will occur. This will be in a more clear way when you can go when we will study the loops. So from that point it will go good. Now this is the one thing that has been happened. Now suppose I want to change the color of this window also. It will happen again. I can go for a tool palette that is in a view, and I want to change the color of this particular box. So I can change the color, not that. Take this color. Okay, and I want to change the color of inside. Like let's take a red color or pink. So you can point out from here. Sorry. So for input, like I take pink, and for the output, let's take some other color. Let's take yellowish color. So if you want your GUI to be very intuitive, you can just change the color also for your control palettes, your inputs and your outputs. So next, suppose now I want to save this VI, then I can save as, suppose I will save as, and suppose the desktop, I can put it like LabVIEW Environment. And okay, so this is how I can have this my environment available. So this is how you can go for the LabVIEW, and it is a very intuitive platform where you can put, or you can have this you can have a very intuitive, you can create a very attractive front panel, like control panel, and by using that control panel you can remotely working on something, so working on some real-time projects. So this is how the LabVIEW environment work. It is a very good environment if you have if you want to create a very good test bench. So whenever you have facing a problem in testing, in data acquisition and in the control application, you can go for a LabVIEW. So it is not something like it is an electronics based or electrical based system. No, the LabVIEW has power to integrate with any kind of hardware. Like it has a very good flexibility with the NI hardware, obviously, but that does not stop you if you are working in a very at any third party hardware like a PLCs. You can integrate a PLC, you can with the LabVIEW, and you can acquire the data. You can have some very intuitive HMI in your LabVIEW using a SCADA or a DSC module. Or you can have like if you want, you were working on some ANSYS project, like to create a dashboard of some automobile vehicle. You can integrate the ANSYS with the LabVIEW also. So this is what the LabVIEW give you the edge in your project. So thank you for this.